Good morning, afternoon, evening to my advanced topics scholars. Today is our first lesson into our journey through our course content together. I'm going to spend some time expanding upon some of the workflows that you'll be tasked to complete throughout our time together. So, currently, you should be looking at slide 1 of your Desmos activity, where we have our lesson objective and the vocabulary terms for our particular section. So first and foremost, right, our vocabulary here that I've just circled or placed a circle over. Oops. See if I can move this. I cannot. Right. You're tasked with defining those terms. While yes, I know you can simply just Google them and copy and paste, I strongly encourage you to read them, process them, and digest them because they will allow you to develop a deeper level of conceptual understanding regarding the content that we plan on discussing. Furthermore, as you can see, our learning objective for today's activity is we are learning about the nature of mathematical reasoning, so I can distinguish between instances of inductive and deductive reasoning. I'll know I've got it when I can provide examples of my own inductive and deductive reasoning. Okay. On your screen, that will appear blank, and you must type and press submit, so that way I know that you at least watched the beginning of this video. Okay. Moving on, let's clear that circle out. On slide 2, we begin our discussion. A big part of becoming an adult is making decisions on your own. List some decisions you'll be making in your last year as a high school student. Okay. While this time wasn't too far away from me, I remember one of those decisions being what comes next? College, grade school, armed services, or an occupation. How do I go about making this decision? What are some variables that I need to consider to begin with? Right, you'll press share with class and you'll see what all of your peers have to say about that as well. Okay. Now, I'm interested to know, is it smarter to make decisions based on a coin flip or to take a few minutes to analyze the situation based on logical thinking? Whichever option you select, please explain your thinking. Which brings us to our first type of reasoning, that being inductive. We call the process of logical thinking reasoning. There are two types of reasoning that you can utilize in your everyday thinking. They are inductive or deductive reasoning. Okay? Normally, you don't turn around and say, "Oh, I'm applying inductive reasoning in this case," or "I'm applying deductive reasoning in this case," right? It's just like, "Well, how'd you think about it?" And then you just kind of say how you thought about it. But you have a firmer grasp of how you are thinking. Inductive reasoning is a process of reasoning that arrives at a general conclusion based on the observation of specific examples. Okay? This is kind of, in layman's term, relying on your intuition. Okay? So, for instance, let's say that I give you a quiz every Friday for the first 4 weeks of school. Starting in October, you may make a conjecture, that's a vocab word, or an education guess that you'll have a surprise quiz next Friday as well. Okay? Please make sure that you are inputting that vocabulary and pressing the submit button. What's going to wind up happening is as you go through and complete all these Desmos activities, you'll have an electronic resource that you can consult long after our time together. So consider it a bit of a digital interactive notebook or a digital Juba notebook. Here, the premise of, I'm going to use the Desmos tool, inductive reasoning. is that we take some specific event from our life and we make a general conclusion. Okay, case in point, like my pattern of behavior with assigning a quiz. Don't worry, I don't assign weekly quizzes. Okay, so your first checkpoint, and this might go back to your glory days in first, second, and third grade, but a game show contestant is given the following string of numbers 1, 2, 4, 5, 7, 8, 10, 11, 13. She'll win $1,500 if she can continue the pattern and fill in the 3 blanks. Use inductive reasoning to determine the rest of the pattern. The reason why we're using inductive reasoning in here is because, as we had mentioned in the previous slide, right, specific to general, general doesn't guarantee an outcome. In the case of the quiz, I could turn around and say, fun Friday, no quiz today, right? And your intuition was incorrect. Not that big of a deal, all right? But keep that in mind as you fill in this pattern, okay? Take the specific mathematical process that's unfolding and extend it, but just know, out of nowhere, I can make the 50th term 0 if I wanted to and make you start over. And obviously this extends to geometrical patterns as well. And as I had just mentioned, while inductive reasoning can definitely be a useful tool in decision making, right? We need to rely on our intuition oftentimes in life. It's kind of how we make decisions. There's one drawback, and the biggest drawback is you can't verify the conclusion for every possible outcome. Yeah, outcome. It is much simpler to prove that something is false rather than true. And oftentimes where we see something like this happen is in the court of law. If you are trying to convict somebody, the defense merely needs to prove that one thing that you are saying is false. Your entire argument is now thrown out the window. That one specific example that you provide is the counterexample. Oops, that should totally say checkpoint 3 at the top. I'll have to edit this activity before I release it. Okay. So mathematically, I'd like for you to take an opportunity to find a counterexample that proves the conjecture below is false. A number is divisible by 3 if the last 2 digits are divisible by 3. Okay. So remember, digits, if I select a number such as, make sure you use this equation editor button, right? Allows you to type math, right? So let's say I select a number of 9,648. The 9, the 6, the 4, and the 8 are considered a digit. So in this instance, we're looking at the last 2 digits and determining if they are divisible by 3, because that's what this conjecture is saying. And we're looking for a counterexample that proves the conjecture false. And once you have your solution, you share that with your class, and you can kind of see what your classmates are thinking as well. Okay. Moving on, we arrive at deductive reasoning. Which is the process of reasoning that arrives at a conclusion based on previously accepted general statements. It does not rely on specific examples. So in this instance, right, we have deductive. We're using some general clause statement that's going to lead us toward a specific action. Okay, this is much more a theoretical style of thinking, but let's take a look at a scenario. So in this instance, right, we need to think of any number, multiply that number by 2. So let's start. Let's think of a number 6. Gets us to 12, right? We multiply that number by 2. Then we add 6 to it. Give us 18. And then divide the result by 2. Gets me to 9. Subtract the original number. So 9 minus 6 is 3. My result here is 3. Okay, that's one specific example. I should do another to see what happens, right? At this point in time, I'm applying inductive reasoning. Right? I'm creating specific instances of a scenario. That way I can conclude some general statement. So let's say I pick 10. 10, I multiply that number by 2, 20, add 6, 26, divide the result by 2, 13, subtract the original number, 10, and I get 3 again. So my conjecture will be the result of this pattern will always be 3. How do I show deductive reasoning? Okay, remember, we want to use a general statement that can be applied for all numbers. Okay, so in this case, oftentimes that we see, actually, I'm going to take a 30-second pause there and not talk about a real life scenario. But if we wanted to apply deductive reasoning, we would start with let x be a number, because x could be any number 1, 2, 3, 4, 5, 6, 50 million. Okay, now we're going to apply this pattern algebraically. Multiply that number by 2. That means we have 2x. 2x is now our numerical value that we're going to add 6 to. Those are not like terms, so our algebraic expression becomes 2x plus 6. We will now want to divide that same result by 2. Oops, sorry. And then subtract from this expression our little keyboard shortcuts. You'll start to learn them over time. The original number. The original number for the algebraic, the deductive style of thinking. And that original number was x. Now when you go to simplify, and I'll write this out for us. Boom, boom, boom. There we go. Now we have this expression, 2x plus 6 divided by 2 minus x. Okay. Back in your heyday, when we had a single term in the denominator, we can apply it to both terms in the numerator because that is our lowest or least common denominator. So 2x over 2 plus 6 over 2 minus x. These 2's will simplify to a 1, and we're left with x. 6 divided by 2 is 3 minus x. And then we can clearly see that these x minus x will create a 0 pair, and our final, oh, go figure, and our final value left will be a 3. So we can actually, I'm gonna hit enter actually, that way. And thus we've now algebraically shown that regardless of what value we pick, we've manipulated the pattern in a way that our final result will always yield a 3. If you don't believe me, try all the numbers that you can possibly think of. Let me know how far you get in about 10 years. And if you find one that doesn't work, we can chat about it. So you apply that same style of thinking here that I had shown in the first example. So here, in our final slide, I give you two scenarios that ask you to apply or determine whether you're applying inductive or deductive reasoning. Right? Please make sure that you explain in both of the scenarios. I'm not going to offer any hints or advice here. I want to see, what your intuition is telling you based on those specific examples that we've come across during this video. Okay, and with that being said, okay, you should be unable to proceed any further because these enhancement opportunities will happen during our class time together in a collaborative manner. Thanks for joining me. I'll pick it back up with you in lesson 2.